Evolution has a weird obsession with crabs. Not casual interest, but full-blown fixation where it keeps making the same thing over and over from completely different starting points. And I'm not talking about a couple species even. I'm talking about at least 5 separate times where evolution looked at something that wasn't a crab and said, you know what this needs? To be a crab. This isn't an internet meme, even though it sounds like one. This is real. This is legitimate documented phenomenon that scientists call carcinization, the process of becoming a crab, which is so specific it got its own scientific term because it keeps happening. And that's what we're going to run through in this video. Our plan is to make you see how despite evolution not having any goals or intentions, being just random mutations and natural selection, somehow it keeps independently inventing crabs given enough time and the right pressures. Different species, different ancestors, different parts of the world, different time periods. Doesn't matter. Eventually, something becomes crab-shaped, and the wild part is, these aren't even closely related creatures that are becoming crabs. We're talking about animals that split off from each other tens or hundreds of millions of years ago, going down completely different evolutionary paths, and then somehow converging on the exact same body plan. So what makes the crab form so special that evolution keeps reaching for it like it's the ultimate answer to some cosmic multiple-choice question? Let's get into it. Studies have shown that the crab body plan is just mechanically and ecologically efficient in ways that are hard to beat if you're trying to be a certain kind of marine creature. To help you understand this, let's break down what makes a crab, at least in terms of body structure. First, you've got the flattened body. Not completely flat like a pancake, but compressed from top to bottom so you're wider than you are tall. This gives you a low center of gravity, which means you're incredibly stable. Hard to flip over, hard to knock around in currents or waves. Then there's the hard carapace, that thick shell covering the body. It serves as protection from predators, obviously, but it also provides rigid attachment points for muscles, which makes your movements more powerful and efficient. Then the abdomen, that's the tail section in most crustaceans. It's folded up underneath the body in crabs, which is huge because it protects your vulnerable underside and keeps your profile compact. You're not dragging a long tail behind you that predators can grab, or a tail that gets caught on things. The legs are also short and powerful, positioned out to the sides of the body. This arrangement gives crabs that famous sideways walking motion that they do. Show footage of crabs scuttling sideways. And it turns out sideways locomotion is incredibly effective for quick escapes and moving through complex terrain like rocky shores or coral reefs. You can easily move fast in any direction without having to turn your whole body around. Put all these features together and you've got an animal that's stable, well-defended, mobile in tight spaces, and can generate a lot of force with its claws relative to its body size. It's a really solid design for life on the ocean floor or in coastal areas. That's why evolution keeps reinventing it. Because when different species face similar pressures and lifestyles, they often evolve similar solutions. This isn't unique to crabs. For instance, sharks and dolphins both ended up torpedo-shaped, even though one's a fish and one's a mammal. That shape is hydrodynamically optimal for swimming fast. On the other hand, different fish groups independently evolved flat bodies when adapting to seafloor life. Rays, flounders, skates all went flat because that's what works on the bottom. Wings then appeared separately in birds, bats, and insects because flying requires certain structural features regardless of what animal you are. So you see, evolution isn't infinitely creative. It works within physical and mechanical constraints. There are only so many ways to build a body that does a specific thing effectively, and apparently, evolution understands that if you want to be a medium-sized armored bottom dweller in marine environments, crab-shaped is one of the best answers. But here's where it gets really interesting and even slightly unsettling. Apparently, not everything that looks like a crab is actually a crab. There are impostors among us. True crabs belong to a group called Brachyura. These are your classic crabs, the ones that actually evolved from a crab ancestor. When a brachyuran has baby crabs, those babies are also true crabs. Basically, the whole lineage is legitimately crab, but then you've got these other creatures that look like crabs, act like crabs, have the crab body plan, but they're evolutionary frauds. They're carcinized, they became crab-shaped, but they're not actually crabs. And the most famous example of them is the king crab. Big, delicious, looks extremely crab-like, sold as crab, tastes like crab. Not actually a crab. King crabs are former hermit crabs that abandoned their shells and went full crab mode. See, hermit crabs have this soft, vulnerable abdomen that they protect by living in empty snail shells. They're born soft, they stay soft, they need that shell their whole lives. But somewhere around 25 million years ago, some hermit crabs started developing harder abdomens. And over millions of years, they built up enough armor that they didn't need the shell anymore. Their abdomen folded up under their body, they got wider and flatter, their legs repositioned, and boom, they looked like crabs. But genetically, taxonomically, evolutionarily, they're still more closely related to hermit crabs than to true crabs. And king crabs aren't the only frauds, apparently. Porcelain crabs. Also not real crabs. They're in the same family as squat lobsters. They independently evolved the crab body plan. Coconut crabs. Those terrifyingly large crabs that climb trees. Also hermit crab descendants. Also not true crabs. They're the largest land arthropods on Earth, and they're living a lie. Even regular hermit crabs that still use shells, they're not crabs either in the taxonomic sense. They're Anomura, which is a different group that just happens to be crab-adjacent. So we've got this situation where nature discovered the crab form is so effective it keeps creating new crabs from non-crab starting material. The crab shape is like an evolutionary attractor that different species keep finding independently. And the funny thing is, this carcinization of crabs probably isn't finished. There are probably lineages out there right now, maybe some species of shrimp or lobster, that are in early stages of carcinization. A few million years from now, they'll be crab-shaped too, and some future scientist will have to explain that, no, those aren't real crabs either. Those are the new fake crabs. All of this tells us something important about how evolution works. There are good solutions and bad solutions to survival problems. And evolution tends to find the good solutions given enough time. The crab form is one of those good solutions. Good enough it's been independently discovered at least 5 times we know of. Good enough there are more fake crabs than real crabs. Good enough that, pause for effect, you have to wonder what else might become crab-shaped eventually. Heh, I mean, probably not, right? We're too far removed, our body plan is too different, we'd have to change too many fundamental things. But for other crustaceans? For things that are already kind of crab-adjacent? Yeah, probably. Give it another 50 million years and we'll probably have a whole new set of fake crabs to catalog. Because it's not that the universe wants everything to become crabs. But if you're a marine arthropod trying to make a living on the ocean floor, evolution will probably try to make you crab-shaped at some point. It's just what happens. It's what keeps happening. And it will probably keep happening. Maybe in a few 100 million years when the sun is noticeably older and Earth's continents have drifted into new configurations, whatever crustaceans exist, then we'll look back at the fossil record and find even more examples of carcinization. Maybe they'll wonder why evolution was so obsessed with this one particular body plan. Maybe they'll make jokes about it on whatever communication system they've evolved by then. Or maybe they won't wonder about it at all, because maybe by then they'll all be crabs too. Humanity will just have to wait and see. Subscribe to watch more videos and turn on post notifications.